At this point, we're going to go ahead and talk about how to do complex calculations when you are in polar form. Last school year, you learned how to do complex numbers when they were in standard form. If you recall, standard form is just where you have it's written in this form, a plus bi, where bi is the imaginary part. This standard form can also be written as x plus yi. That's because when you graph on the imaginary plane, the y-axis is our imaginary axis and the x-axis is our real axis. So this is another way to write a complex number in what's called standard, or also known as rectangular form. So I'm going to focus on this. I'll often use a plus bi when I tell you to put something in standard form, but for the purposes of converting it to polar form, I'm going to use x plus yi. I'm going to show you why the polar form is written the way it is. So our x value, if you remember in polar form, is equivalent to r times cosine of theta, while our y value is equivalent to r sine of theta. And we're multiplying that by I. I'm going to clean that up in a bit. So this is my x value. This is my y value. So the way we write it, though, is we usually factor out that common factor, or the radius. So usually our polar form is written like this. It's the radius multiplied by cosine of the angle plus I sine of the angle. This right here is how you write something in polar form, a complex number in polar form. Now there is a shorthand. Unfortunately, when it comes to the computer, you can't use the shorthand, but you can copy and paste things to make things go a little faster. But the shorthand is written like this, where we just write r cis theta. It means the exact same thing, the c representing cosine, the I representing the imaginary part, and s representing sine. So that's the shorthand. Let's go ahead and see how this works. Actually, before we do that, let's learn about some calculations. So first calculation I want to talk about is how to multiply or divide complex numbers. So I have two generic complex numbers here, z and w. I'm going to be writing them in shorthand when I multiply them. But the way this will work is when you multiply two generic complex numbers together in polar form, you multiply the radius lengths together. So I'll do r1 multiplied by r2. And then I'm going to shorthand it. So this is the cosine and the sine combined. And then you add the angles together. Now, for those who might be curious as to why this works, I actually talk about it, or I make a little note down here. You can prove these properties using sum or difference formulas for sine and cosine. So that's something if you want to explore a little bit, that's how these properties come to be. Now, dividing is really similar. You're going to divide the radius lengths, and then instead of adding the angles, you subtract the angles. And those are kind of your two main operations that we do. Now I'm going to talk about one other operation in a second. The next operation is our powers of complex numbers. So what that just means is, let's say I take z, which we have over here. If I take z and raise it to the nth power, the way you would write this is you would do your radius to the nth power. Now, raising something to the nth power just means you're multiplying it together n times. So you're really adding the angle together n times. So you could write this as n times theta 1 to get your new angle. And that's the power rule. Let's go ahead and do a couple problems where we just multiply, divide first. Okay, so this problem, I'm going to start with multiplying. So I've got z times w. Our radiuses are right here, so I'm first going to do that. I'm going to do 10 times 5. I'm going to shorthand it with cis, and then I'm going to add my two angles together. You'll notice these angles should match up every time, so the 85 and the 85, and then the 20 and 20. So I'm going to add 85 to 20. By the way, it does say we're going to keep it in polar form. There will be times where I'll ask you to switch back to rectangular form or standard form. So this problem, 10 times 5 is 50. And then 85 plus 20 is 105. And I should probably have my degree markers in. But that's our answer. Now remember, this is shorthand. So just as a reminder, if you have to type it in the computer, you will have to type 50 and then cosine of 105. You don't have to put the degree symbol, but I'm going to write it. Plus I sine and then 105 degrees. And that would be the longhand version of that operation. Let's do division. So division, I'm going to first divide them. So I've got 10 divided by 5. We'll shorthand it. And then this time we subtract the angles. So 85 minus 20. And I'll keep this one in shorthand. So we've got 2. 10 divided by 5 is 2. And then 85 minus 20 is 65 degrees. And I'll just leave it as shorthand, but that would be our answer. Okay, let's do the same thing. This one's just in radians, but I'm still going to keep my final answers in polar form. Sometimes they'll use the term trigonometric form. They mean the same thing, just means you're going to have sine and cosine in the end. So let's start with z times w. So z times w, I'm going to go ahead and do my radiuses multiplied together. I'm going to shorthand it. And then I'm going to add 5 pi twelfths to pi eighths. Now 36 times 9 is 324. And then before I add these, I'm going to go ahead, since I'm going to need it anyway, up here, I'm just going to convert those angles so that they have the same denominator, since I'll need it for subtraction anyway. So 5 pi twelfths, I could get a common denominator of 24. So I can multiply the numerator and denominator by 2. And then for the pi eighths, I'll multiply the numerator and denominator by 3. So we'll get, our first angle will be 10 pi 24ths, sorry. And then the second angle will be 3 pi 24ths. So when we add those, 10 plus 3 is 13 pi 24ths. And we're leaving it in polar form, so that is my answer. Let's do division. So z divided by w, so I'll do 36, divided by 9. And then this time we are subtracting them, which we now have a common denominator, so that will make life a lot easier for us. So 36 divided by 9 is 4. And then I'll keep the shorthand, but 5 pi twelfths minus pi eighths, remember we're going to come back to this, so that's really just 10 pi 24ths minus 3 pi 24ths, which is 7 pi 24ths. So that's kind of how multiplication and division work.